Yes, the story is plausible. It is possible for a main breaker to explode and burn up when power is restored without proper precautions. There are several possible causes for this. Firstly, a short circuit which occurs when there is a low resistance path between the hot and neutral wires. This can cause a massive current surge that can overload the breaker and cause it to fail. Secondly, loose or damaged connections can create high resistance points which can lead to arcing and overheating. If the arcing is severe enough, it can ignite the insulation and cause a fire. Thirdly, if the circuit is overloaded with too many appliances or devices, it can draw more current than the breaker is designed to handle. This can cause the breaker to overheat and fail. Fourthly, a defective breaker may not trip properly when there is a fault, allowing a dangerous amount of current to flow through the circuit. To avoid similar incidents, follow these precautions. Always check for faults before resetting a trip breaker. Inspect the circuit for any loose or damaged connections, frayed wires, or burning smells. Use a voltage tester to confirm that the circuit is safe before resetting the breaker. If the breaker trips repeatedly, do not reset it. Call a qualified electrician to diagnose and repair the problem. Upgrade the electrical system if necessary. If the circuit is consistently overloaded, you may need to install a higher rated breaker or add additional circuits. Regularly inspect and maintain your electrical system. This includes checking for loose connections, damaged insulation, and any other potential hazards. An electrical system is designed to safely distribute power throughout a building. Understanding its components and potential hazards is crucial for preventing accidents and ensuring safety. Let's discuss some key concepts. A circuit is a closed loop that allows electrical current to flow from a power source to a load and back. The power source provides the voltage that drives the current, and the load consumes the electrical energy. Circuits are typically protected by circuit breakers or fuses, which are designed to interrupt the flow of current in the event of an overload or short circuit. A short circuit occurs when there is an unintended low resistance path between 2 points in a circuit with different voltages. This results in a very high current flow, which can quickly overheat wires and cause a fire. Overloads occur when a circuit is drawing more current than it is designed to handle. This can happen if too many appliances are plugged into a single circuit, or if an appliance has a malfunction that causes it to draw excessive current. Overloads can also cause wires to overheat and potentially start a fire. Grounding is a safety measure that provides a low resistance path for fault current to flow back to the source. This helps to quickly trip the circuit breaker or fuse and prevent electrical shock. Grounding is typically achieved by connecting the metal enclosures of electrical equipment to a grounding electrode, such as a ground rod or a metal water pipe. Arc faults are dangerous electrical discharges that occur when current jumps between two conductors. Arc faults can be caused by damaged insulation, loose connections, or corrosion. They can generate intense heat and are a leading cause of electrical fires. Arc fault circuit interrupters or SIs are special types of circuit breakers that are designed to detect arc faults and quickly interrupt the flow of current. SIs are required in many areas of the home, particularly in bedrooms, living rooms, and dining rooms. Ground fault circuit interrupters or GFCIs are designed to protect people from electrical shock. GFCIs monitor the current flowing in hot and neutral conductors of a circuit. If there is a difference in current, it indicates that some of the current is leaking to ground, which could be through a person. The GFCI will quickly trip the circuit, interrupting the flow of current and preventing electrical shock. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Electrical panels are the central distribution points for electricity in a building. They contain the circuit breakers or fuses that protect the various circuits in the building. Electrical panels should be properly labeled to indicate the circuits that they control. It is important to know the location of the electrical panel and how to turn off the power in case of an emergency. Wiring is the backbone of an electrical system. It is important to use the correct size and type of wire for each circuit. Wires should be properly insulated to prevent short circuits and electrical shock. Wiring should be installed in accordance with the National Electrical Code or NEC and local electrical codes. Electrical codes are sets of regulations that specify the safe installation and maintenance of electrical systems. The NEC is the most widely adopted electrical code in the United States. Electrical codes are designed to protect people and property from electrical hazards. It is important to be familiar with the electrical codes in your area and to follow them carefully when working on electrical systems. Electrical safety is everyone's responsibility. By understanding the basics of electrical systems and following safety precautions, you can help prevent electrical accidents and ensure a safe environment. Always use caution when working with electricity, and if you are not comfortable performing a task, hire a qualified electrician. When dealing with electrical issues, it's crucial to prioritize safety above all else. Before attempting any electrical work, ensure the power is completely turned off at the main breaker or fuse box. This simple step can prevent serious electrical shock or electrocution. Double check that the power is off by using a voltage tester on the wires or devices you plan to work on. Never assume the power is off just because the switch is in the off position. Always verify with a tester. Working with electricity requires the right tools. Use insulated tools specifically designed for electrical work. These tools are designed to protect you from electrical shock. Avoid using tools that are damaged or have exposed metal. Wear appropriate personal protective equipment or PPE, such as safety glasses and rubber gloves. Safety glasses protect your eyes from flying debris or accidental sparks. Rubber gloves provide an extra layer of insulation to protect you from electrical shock. When working on electrical panels, be aware of the potential for arc flash. An arc flash is a dangerous electrical explosion that can occur when there is a fault in the electrical system. Wear appropriate arc flash PPE, such as a face shield, arc-rated clothing, and gloves. Never work alone on electrical projects. Have someone nearby who can assist you in case of an emergency. Make sure they know how to turn off the power and call for help. If you are not comfortable performing an electrical task, hire a qualified electrician. Electricians have the training, experience, and equipment to safely perform electrical work. Attempting to do electrical work yourself without proper knowledge can be dangerous and may violate electrical codes. Before starting any electrical project, obtain the necessary permits from your local building department. Permits ensure that the work is done in accordance with electrical codes and that it is inspected by a qualified electrical inspector. Inspections help to identify potential safety hazards and ensure that the electrical system is installed correctly. Regularly inspect your electrical system for any signs of damage or wear. Look for frayed wires, loose connections, cracked insulation, and other potential hazards. If you find any problems, have them repaired immediately by a qualified electrician. Avoid overloading circuits by plugging too many appliances into a single outlet or circuit. Overloading circuits can cause the wires to overheat and potentially start a fire. Use power strips with surge protection to protect your electronic devices from power surges. Power surges can damage sensitive electronic equipment. Install arc fault circuit interrupters or size in your home to protect against arc faults. Size are especially important in bedrooms and other areas where people are sleeping. Install ground fault circuit interrupters or GFCIs in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. GFCIs can save lives by quickly interrupting the flow of current in the event of a ground fault. Keep electrical cords and appliances away from water. Water is a good conductor of electricity and can increase the risk of electrical shock. Never use damaged electrical cords or appliances. Damaged cords can expose live wires and create a shock hazard. Replace any damaged cords immediately. Use extension cords safely. Do not overload extension cords or run them under rugs or furniture. Extension cords are intended for temporary use only. If you need a permanent source of power, have an electrician install an outlet. Teach children about electrical safety. Explain the dangers of electricity and how to avoid electrical shock. Keep electrical outlets covered with safety caps when not in use. Have a qualified electrician inspect your electrical system periodically to ensure that it is safe and up to code. Regular inspections can help to identify potential problems before they become serious. Follow these safety tips to protect yourself and your family from electrical hazards. Electricity is a powerful force, but with proper precautions, it can be used safely. Remember that working with electricity can be dangerous, and it's always best to err on the side of caution. If you're unsure about any aspect of electrical work, seek the help of a qualified professional. A seemingly simple task like resetting a trip breaker can turn catastrophic if the underlying problem isn't addressed. The initial situation described highlights the importance of not just flipping a breaker back on without investigation. When a breaker trips, it's a sign that something is wrong. Ignoring that sign can lead to serious consequences, including fire and damage to your electrical system. A short circuit is one of the most common causes of a trip breaker. It occurs when there's an unintended path for electricity to flow, typically between a hot wire and a neutral or ground wire. This creates a surge of current that exceeds the breaker's capacity, causing it to trip. Identifying the source of a short circuit can be tricky, but it often involves looking for damaged wires, loose connections, or faulty appliances. Loose connections are another frequent culprit in electrical problems. Over time, connections can loosen due to vibration, temperature changes, or simply age. Loose connections create resistance, which generates heat. This heat can damage the insulation on wires and lead to arcing, which is a type of electrical discharge that can ignite nearby materials. Overloaded circuits are also a common cause of trip breakers. Every circuit is designed to handle a certain amount of current. If you plug in too many appliances or devices into a single circuit, you can exceed its capacity. This will cause the breaker to trip, preventing the circuit from overheating. Defective breakers themselves can also be the problem, although this is less common. A breaker might fail to trip when it's supposed to, allowing excessive current to flow. Alternatively, a breaker might trip prematurely even when the circuit isn't overloaded. If you suspect a defective breaker, it's important to have it replaced by a qualified electrician. Prevention is key when it comes to electrical safety. Regular inspections of your electrical system can help you identify and address potential problems before they lead to a dangerous situation. Look for signs of damage, such as frayed wires, cracked outlets, or scorch marks. Pay attention to any unusual smells, such as burning plastic or ozone. If you notice anything out of the ordinary, have it checked out by an electrician. When a breaker trips, resist the urge to simply flip it back on without investigating. Take the time to identify the cause of the trip. Check for overloaded circuits, loose connections, and damaged wires. If you can't find the problem, call an electrician. Don't take chances with electricity. Electricity is a powerful force, and it can be dangerous if not handled properly. Always follow safety precautions and seek the help of a qualified professional when needed. The NEC is a comprehensive set of standards for electrical installations. It covers everything from wiring methods to grounding and bonding requirements. Following the NEC is essential for ensuring the safety of electrical systems. Local electrical codes are often based on the NEC, but they may also include additional requirements specific to the area. It's important to be familiar with the electrical codes in your area and to follow them carefully when working on electrical systems. A voltage tester is an essential tool for anyone working with electricity. It allows you to safely check whether a circuit is live or dead. Before working on any electrical circuit, always use a voltage tester to confirm that the power is off. There are different types of voltage testers available. Some are designed to detect voltage without making contact with the wires, while others require direct contact. Choose a voltage tester that is appropriate for the task at hand. Remember, electrical safety is not just about following rules and regulations. It's also about using common sense and being aware of the potential hazards. Always think before you act, and never take risks with electricity. By taking these precautions, you can help prevent electrical accidents and ensure a safe environment for yourself and others.